Hello, everyone. Welcome back. In the next hour or so, we're going to go through more Python stuff, how to build more logics into Python. But before we get started, let me go through some logistics. So first, if you are already in CodeCalc, let me navigate you through where you can find the lessons for this one. So you can connect on the top left, the projects, then go to material project workshop. Then here you can connect this home button here in the middle of your screen. Then you can go to, if you scroll down, you can go to workshop, then primer, then O2, Python part 2. So, and also you can see all the stuff here. I'm at home, workshop, primer, O2, Python part 2. That's where all the course materials are for this lesson. So within this directory, there are a few Jupyter notebooks. There's one called lessons.ipynb. That's a Jupyter notebook. For the lessons we're going to go over in this course. If we click it, it will pop up. Let me close it. There's another one called exercises. Here we have all the exercises we're going to go over together during this course. And also there's another Jupyter notebook called exercises _ solved. That notebook has all the solutions to the exercises. Okay, so you can go along with me by taking a look at this lessons Jupyter notebook, but I do suggest you to open a new notebook and do all the exercises together with me. To do this, here in the middle of your screen, you can see a new button here. You just click it, then it will pop up, pre-filled some date string as showed by Sham earlier today. Then you can click this Jupyter notebook stuff to create a new one. Let me click it. It will create a new one. Here you have to select a Python kernel. Let me select this Python 3 stuff. Here we go. We get a new notebook. So hope you have done this. Let me close this. I have prepared some stuff. Let me just open that. So that is the lesson. Here in this notebook, it's just an empty notebook. I have prepared some stuff. We will go through all the stuff together. So okay, thanks Kyra first for the wonderful introduction of Python for the first part. In the second part, we are going through more Python building blocks. Specifically, we will talk about conditionals, how to do if statements, and also we're going to talk about dictionaries that maps the key to a value. And then we will talk about functions, how to break your code into pieces. And finally, if we have enough time, we will have a snap talk about classes. Okay, let me start with the conditionals, right? So as Kyra has briefly talked about in the first part, when we write our code, sometimes we want to make decisions based on some conditions. If the condition is true, when we want to execute some code, if the condition is not true, in other words, if it is false, we may not want to do it. So this is very similar to other languages. If you have experience with them, if you have no experience with coding, it's not a problem. In Python, it's pretty easy to do it. It's very similar to our natural language. Here, I just show it. This is some pseudocode. I will give examples after this, right? So to do this if statement, we have the if keyword, then some conditions. Then Python will check whether a condition is true or false. Based on the checking, it will decide whether to do to run the code within the indented block or not. Also, if you have multiple conditions want to check, you can use the else statement. Else simply means else if, and also you can use a catch-all statement to catch other cases that does not satisfy all the conditions. Okay, all that being said, let's start with examples. So that should be easier to understand, right? First, let's do, as I said before, we need conditions. If conditions is true, the statement will, the code block will be executed. Then in Python, you can easily create variables for true or false. That is what we typically call Booleans. Here, let me create a Boolean called B1 space equal sign true. So this is how we create a Boolean variable. Remember, the first letter here should be capitalized. That this two with its first letter capitalized is a Python keyword. Then if we execute it, Python will know this variable B1 has been assigned a value of 2. Let us see what the value is. Press B1 to run this code. Remember, we can do Shift Enter. Let's do it. Here, Python just Jupyter Notebook just tells me this B1 is 2. Similarly, for Boolean variable, we have another value that is false. Let's do B2 equals false. Again, the first letter should be capitalized. Let's run this by Shift Enter. Show the value B2, Shift Enter. Here we go. We see we have the Boolean variables 2 and false. Then use this 2 or false. We can replace them as the conditions. Then we can do the if statement. Let's do an example. If space B1, then a column. If you press enter or return, it will be in an indented block. Let me do some stuff simple, that is print hi. If we run this code again by Shift Enter, it will just print the stuff we entered in the print statement, print function that Kara talked about earlier. So here we see because the Boolean variable B1 is 2, then Python says that okay, it is 2. I will run the code in this block. Then what if this condition is false? As you may guess, Python will definitely not do this, not run it, but let us show it. We do if B2 column, then print hi 2. If we run this, you see nothing is printed out because the condition is false, right? Okay, so to do this, all this if statement, here we just use Booleans B1 and B2, but in principle, you can plug in any Python variables there. It does not necessarily need to be a Boolean. For example, we can use an integer here. I define a variable I equals 3, that is an integer. Then I can do if I, then print I. If I run this, it will simply print out 3. In this case, the variable I will be regarded as 2. So in Python, in principle, as I said before, you can put any variable here. Most of the variables, they will be regarded as 2, but there are some special ones, they will be regarded as false. For example, if you put an 0 there, it will be regarded as false. If you put an empty string, if you put an empty list, they will be regarded as false. Let me show this. if string here, I just put an empty string here as a condition, then let's say, let's print it. Oops, print, let's print hi, because an empty string will be regarded as a false, then nothing will be printed out here. So there's something a little bit tricky. For example, let's define a list called A, then let's put a 0 here, right? As I said before, if we as I said before, empty list and zeros will be regarded as false. But what about a list of 0 here? We can check it, right? What do you think this value will be? Actually, it will be 2. This A will be regarded as 2, because for list and other container data structure like tuple, we haven't covered it. As long as this this variable or data structure is not empty, it will be regarded as 2. Here it is not empty, even though we put an number 0 here. Okay, not only variables, but also we can use, but also there are some expressions that will be regarded as true or false. For example, we can compare the values of 2 integers. If we do 5 larger than 2, if we run it, this is 2. We can compare whether two integers are the same. 5 equals 5, right? Of course, it is true. Here, remember, we have to put 2 equal sign here. If we just put 1, it is the assign operator. It will assign a value to some variable. So, but for comparison between two values or 2 variables, we have to use this double equal sign. So, so far we've only talked about this part, right? If condition, let me do this. If condition, then do some code or not. But as I said before, if we have multiple conditions, we can do it. We can do it as well for this conditional check. Let's do an example below. For this example, let's check the phase of water at different temperatures. For example, let's define a variable called temp equals 150 Celsius. Let's say if temp is larger than 100, we know that this is in gas phase, right? So we print gas here. Then when we want to do some additional check, we can do if temp larger than 0, print liquid. Right? We know that if a temperature is in this range, above 0, but below 100, it will be liquid. Then for other cases, we can do else column. Then within the indented block, we can print its state. We know it's ice, so it should be in solid. Let me correct this. Okay, if we run the cell by pressing Shift and Enter, we say if the temperature is 150 Celsius, then Python will first do this first conditional check. Of course, it is satisfied. Then it will run the code within this block. Here it is print this gas stuff. Then it's done. After a condition is satisfied, all the code blocks below this condition will be ignored by Python. So let's do another check for different temperature. Let's do 50 Celsius. if we run this, it will check the first one. It's not satisfied, then it will check the second else, that stands for else if statement. Then we'll enter this block and print liquid here. Apparently, if we do a temperature below 0 Celsius, it will print solid. One thing I want to emphasize here, from my personal experience and some of others' experience, often when you write this if else statement, sometimes you just write if else and you forget this else statement. This may cause a lot of problems. So most of the time when you write this kind of else if statement, you may want to add a else statement below it to catch all other cases. Okay, this is all I want to talk about for conditionals. Let's turn to the exercises. Let me close this. Then the exercise again is in the home workshop primer O2 Python part 2 directory. Let me connect it. Oh, sorry. It should go to exercises. So for this, for the exercise for lesson 5 conditional is to ask you to convert temperature between Celsius and Fahrenheit. Here I provide the formula. So simply you are going to do some filling by replace this underscore field underscore, and here it is again with your implementation. Let's take a few minutes, let's say 2 minutes or 1 minute to finish it. Then I will and then we will work through it together. Okay, hope you had the chance to go over the exercise and do your work. Now let's go over it together. Here, as an input, I define a variable t. This t basically has two parts. In the first few characters, I given the value of a temperature, and in the last character of the string, I give the unit of the input temperature. Then in this block, I just separate them into two parts. The first one, in value, that is the first two of this, the first parts of this temperature input, that will be the values. For example, 68 here. The second part is the unit. It will be either F or C, depending on your input. Then in the block here, we will do some check based on the input units. We want to get the output value and output units. So this is kind of simple. If you take a look at this output unit, because our output unit is in Fahrenheit, you may have guessed that the input should be in Celsius. Let me just replace it, delete it by input everything in quotes. Then I should enter a capitalized C, because here I use this function, dot upper function. no matter what you input here, no matter it is in lowercase or uppercase, it will be converted to uppercase. So we will end up with getting F in the end. So similarly for this one, as you would guess, we would put F here. That stands for Fahrenheit. So if we run the cell, we see that the temperature 68 Fahrenheit is 20 Celsius. For another input, let me try. Just uncomment it, then comment it by adding a pound sign between it. Let me run it again. This says the temperature 30 Celsius is 86 in Fahrenheit. Okay. If you don't finish it, don't worry. We have the you can ask it later. You can do it later or ask us after the lessons via Slack. And also we have the solutions. Let's go back to the lessons. I have the live lesson. Here we go. Okay, so let me just talk this header to give more space. Oops. Okay, so we've just talked about conditionals. Then let's talk about dictionaries. In the first part, Kara talked about lists. List is simply a sequence of stuff, right? It is ordered. You can put whatever you want in the list. You can put strings, integers, floats. So Python does not matter, does not care about it. So for dictionaries, it's another data type that is built in Python. For list, if you want to get access to some member or some element or component, you have to use the index. So in principle, a list is an ordered data structure. But for dictionary, in principle, it is not ordered. It is not ordered. We get access to a dictionary value using its key. So the syntax for dictionary in Python is as shown here. We define a dictionary using the curly bracket. Then within this curly bracket, we put some key and then some value. Between this key value pair, we put a colon. Of course, a dictionary may contain many key value pairs. So to separate different key value pairs, we just use this comma, right? This is the basic syntax of Python dictionaries. Let's do examples to show how it works. For this example, let's create an elements dictionary that maps the name of an element, of a chemical element, to its atomic number. Let's do elements equals curly bracket. For the first element, let's do hydrogen. Then for hydrogen as the key, the value that is the atomic number for hydrogen is 1, as you know. Let's do another key value pair, for example, carbon. Then again, the value is 6. If we run this, we just assign this dictionary to a variable called elements. We can check its value by print it out, print elements. So in Python, in Jupyter Notebook, many times, if you don't want to type that much, you can press the tab. Then it will pop up some of the available parameters or variables. You can then click it. It will fill it automatically for you. Then we can press Shift Enter to run this cell. Here we see this is just the same syntax as we entered. That is how we denote a dictionary in Python. So once we have created this dictionary, we may want to get access to its values, as I said before. for list, you get access to a value using its index. For elements, we use its key. Let's do an example. Elements carbon. Let me run this. Oops. I get an arrow. Here it says key arrow, carbon. If we go back, okay, here we go. When I define this elements dictionary, I use the first letter of carbon is capitalized, but here when I call it, I just used lowercase. So a string with capitalized letters or lowercase letters, they are different. So I have to correct this, change it to uppercase C. Let me run it again. Here we go. We say that we can get access to this to the value of an key value pair using its key and this square notation. This is again very similar to a list. In list, you input the index of a component in the list, but here we just input the key for it. For Python dictionary, we have many operations for it. For example, we can add new key value pairs to it. Here, let me add one elements copper. To do this, again, we use the square bracket notation. Put the key you want to add inside this square bracket. Sorry. Then you use this. You put an equal sign to assign some value. Let's do copper. If we run it and again show the value, we see this new key value pair has been added to this dictionary. If you are careful enough, you may have noticed that I made an error here. So because the atomic number of copper should be 29, not 27. So we can correct this very easily. Again, we use this square bracket notation. We type elements, then copper. We just do the same stuff as we do before. Simply assign 29 to copper. If we run this and show the value, we see the value of copper has been changed to 29. So if when you do this square bracket notation, assign notation, if a key is already in the if a key is not already in the dictionary, it will be added to the dictionary. As we see here, it is not in. When we do this, it will be added in. But if the key is already there, it will simply change the value of the key in the dictionary. Okay, here, this is how you add a single key value pair to a dictionary. We may want to add multiple key value pairs, right, at the same time. To do this, Python dictionaries have some built-in functions to do it. Let me first define a dictionary that we want to add in to this elements dictionary. Let's call it D equals, again, using the curly bracket to create a dictionary. Let's say nitrogen, that's 7, comma, then oxygen as a key, then a colon, the value after the colon. We define a new dictionary called D. If we want to add this dictionary D to the elements dictionary, we can simply call elements dot update, then a parenthesis, within this parenthesis, we input this D. This is basically call some function that I will cover later. How this is built, how you can build this kind of stuff. So for now, let's just do it. If we do that, if we run this cell, and again, let me show the value of elements. We see once we call this update function, the values of this, the key value pairs in this D dictionary will be added to our elements dictionary. So let me add new cells. To do this, you can simply click adding cell, but then press ESC, then press B. You can add many cells below it. Another function I want to talk about is pop, right? So here we've just talked about how to add new key value pairs in your dictionary, but sometimes you may want to remove some key value pairs from your dictionary. To do this, as I said, we can use the pop built-in method of dictionary. We do elements dot pop, then parentheses after it. Within this parenthesis, we just give the value of a key value pair that we want to pop, that we want to remove from this dictionary. Let's remove oxygen. Then after that, let's print the value of elements. If we do this pop function, then again show the value of this dictionary. After doing it, we see the key value pair of oxygen and 8 has been removed from it. Okay, the last bit I want to talk about for dictionary is looping. Looping over dictionary is very, very similar to looping over a list, as talked about by Kara. So we do for, then some variable we want to assign the value. Let's do I. For I in elements, then a column. Then we can put in this indented block. Let's check what's the value of I. If we run this, you may see Python will simply give you the keys, give you all the keys one by one in this dictionary. There's another way to loop over Python dictionaries, because sometimes you may want to loop over the key and the value together. For that, we can call the items built-in method of a dictionary. So let's do I for I, comma j in elements dot items. IT. Here we go. Don't forget the parentheses here. By calling this dot items function of the elements dictionary, we will loop over key value pairs at the same time. And then the key will be assigned to I, and the value will be assigned to J. Let's check this by printing them out. Print key I, print Y, V stands for value J. If we run this, here we go. We see there will be I and J will be accessed together at the same time. Okay, that's what I want to talk about for dictionaries. Let's switch to the exercises. So for lesson 6 dictionary, we have 2 exercises. For the sake of time, let's skip exercise 1. You can finish it afterwards. Let's now focus on exercise 2. Again, I will probably give you 1 minute to read through this exercise. Then we can work together on it. Okay, let's continue. Hope you have the time to read through the exercise. In this exercise, we ask you to compute the weights of a molecule. We give you two dictionaries. The first one is the atomic weights dictionary that maps the name of an element to its atomic weights. We give another dictionary, for example, water, that maps that tells you how many atoms that tells you how many atoms are in this molecule by its elements. So to do this work, we first load this atomic weights dictionary from the atomic weights dictionary data from disk. You don't need to worry too much about this. The only thing you want to know is that atomic weights is some dictionary, as shown here. Then for water, it is a defined dictionary for you. Then to compute the weights, we use a for loop to loop over a molecule. Here, the key is a symbol. The key is a symbol of the molecule. The value is the count of the count. The count is the number of atoms in this molecule. So we can do atomic weights, then get the symbol, get the atomic weight of a symbol, simply multiply the count. Here, because we initialize a weight equals to 0, then we use this plus equal sign to iteratively adding all the weights of different chemical species to this weights, to the total weights. If we run this, it says name symbol not defined. I may have a typo here. Here we go. It should be symbol. Yes, it just print out the value for it just print out the weight, molecular weight for water. Of course, you can, if you uncomment this one, you can do another example for caffeine. Okay, let's switch back to the lessons. Here we go. Oops, it's not responding. I just want to toggle the head to give more space. Here we go. Okay, now let's talk about functions, right? Kara has already mentioned a little bit about functions, about Python built-in functions, like the print function and also the math module from the built-in Python library. So now let's talk about the syntax of a Python function. You can, and also how to define a function by yourself. For a Python function, you first use some def keyword, then a space, then a function name for the function. By convention, for Python function names, we use lowercase words and also collecting the words by an underscore. This is just a convention. You don't need to follow it, but we do strongly recommend you to do that. So most of the people do that. So this is about the Python function. Then Python function name. Then after the name, you will add a parenthesis again. In this parenthesis, you can add some parameters for your function. You can add as many as you want. After function, you have a colon to indicate that the function will enter an indented block. Then with this indented block, you can do whatever code you want, some calculations you want your function to perform, and optionally you may want to return some value from your function. And also the parameters, they are also optional. Even the code, they are optional. You don't need to do anything in your function. Okay, this sounds a little bit too abstract. Let's do examples that may be easier to understand, right? So for the first example, let's define a function by typing the keyword def, then space, let's say hi. In this function, we do not have any parameters, so we leave it blank in the parentheses. Then after it, don't forget the colon that's required. Within this indent block, we just print some stuff that is hi. Executing this code, run this code by press-shifting enter. We just tell Python that we have defined a function called say hi, just need to know. Then to call this function, we simply type the name of the function, say hi, then a parenthesis. Don't forget the parenthesis. Run it again. It will execute the code we put in the indented block of this function. Here we go. This is the very first function that we have written by our own. So this is simple, but we can add in more stuff into it. As we said before, we can add parameters to a function. Let's do an example. Def say hi to another say hi function. This time, this function has an argument called name. And a function argument is nothing but a variable. As any regular variable, you can think it of. Then after the parentheses, don't forget the colon. Then in this indented block, we just print hi name. Run it. Then call this function again by typing its name. I just type the C underscore, then I pressed tab. Then Jupyter Notebook already knows I have two variables having this name pattern, then I can choose between them. Here I chose say hi to, then parentheses. Here our function has an argument. Then we need to provide this argument. Here we just provide a string. We type a quotes. In this quotes, we do Berkeley. Run this function. It says hi Berkeley. So this is simple. When we call this function, this Berkeley will be assigned to this variable or parameter name. Then we call this print statement. It will be print out. So as we said before, a function can also return some stuff. Right here for the say hi function and say hi to function, they don't return any stuff. Let me do an example of a function that returns some stuff. For this example, let's compute the magnitude of a two-dimensional vector. Let's def get vector magnitude. For a two-dimensional vector, we take two parameters, the x component of the vector and the y component of the vector, then colon. To compute the magnitude, we can call the function, the built-in function in the math library, that is math.sqrt. Let me finish this and I will explain. X, Y. Here we go. So in this line, here this x double star 2, that is the exponential operator, simply compute the square of a variable. Then we sum them up. Then we call this sqrt function. That is a function from the core math library. you can simply use it. It computes the square root of something you input in its parentheses. Then to return the value, we can type return mag, right? Mag simply stands for magnitude. That's our output. Okay, let's run this. Let's call it get vector magnitude 3, a vector with x3 and y of 4. If we run this again, we got some arrow, name mice. It's not defined. Yep. Yeah, we use this mice here. As Kara said, if you want to use some library that is not the built-in functions, you have to import it first. So let's import mice here. Run it again to let Jupyter know that we have redefined it. Then run the cell below it again. We see if we run this get vector magnitude function with 2 parameters, Python will just assign the value 3 to the first variable x and the value 4 to the second variable y. Then do whatever you ask it to do in this function, and finally return the value. Here we just return the value, but what about a function without this return statement you put it there? Let's check what it will do, right? Print c. Let's do print c hi, our first function that is defined here. Simply print some stuff. So you see, when we print this function, we print out 2 stuff. The first one is hi, the other one is none. The hi is actually printed out by the print statement in this function, and the none is essentially the return value of this function. Okay, this is simply not good. Let me do another way. It's too bad to demonstrate it. Let's assign this return value to a variable called a. Let's run it. Again, we call this function. It will print out this. But let us then check the value of this returned variable. If we print it a, it will be none. So this means that for Python functions, you can add a return statement in your function, but if you don't add it, by default, Python will add one for you. That is return none. So if you don't need it, you can simply ignore it. But sometimes this may be useful for some error checking or something like that. Okay, this is what I want to talk about for functions. Let's move to the exercise. Let me close this one, open exercises. Again, for the functions exercise, I have 2 exercises. Let's skip exercise 1 and you can finish it later. For now, let's focus on exercise 2. This is very, this exercise is built up on our temperature conversion exercise in lesson 5. So you must be very familiar with it. Here, I just want you to practice how to reorganize your code into a function. Again, you need to replace the __ field __ with your own implementation. Let's take 1 minute to do it. Okay, let's continue with this exercise. So as I said before, this is just some reorganize of the code of the temperature convention code we read before. For this convert temperature function, it takes two arguments. The first one is value. We've separated them into two. In the previous one, the input is just one string. Here we just simply separate it into two. Value, it could be 30 or whatever. It should be a number. Then we have another parameter that is the unit of the temperature. Here you see in this function, I have already assigned a value C in it. This is what we call default parameters. When you call a function, you can do this. Then when you call it, you don't need to pass it. If you don't pass it, then Python will use this, use the value you assign here by default. So to finish this, here we check if the unit.upper again convert any character into its capitalized case. It is equals to C. Then we know if the input is in Celsius, we may want to convert it into Fahrenheit. So the output should be Fahrenheit. But for the output value, let's simply copy what we have above, right? For this exercise, we have, if units is C, the output should be, we should use this formula to do the computation. Let's copy it. Then here we go. Scroll down and paste it. Here, remember we have to change the name a little bit. Here, the input parameter value is just value. Here, in the previous one, we use in value. We just need to make them to be the same. Similarly, for the other case, if the input is in Fahrenheit, we need to convert it into Celsius. For the expression again, let me simply copy what we have above. Replace this one. Again, we need to change the name. So this is it. We can run it. If we run this cell by pressing enter, we see we have defined this function. We call this function, and this function returns two values. The first value, out value, will be assigned to V. The second value, out unit, will be assigned to unit. Then we just print it. As I said before, for function, because we define some default units here, when you call this function, once it has some default value. Once this parameter has some default value, you do not need to pass to it. Let us check this. Here, I just pass one variable 30. That will be passed to value. Then unit will be whatever it is. It is C here. That is the default. Let me run this cell again. You see, this runs as expected. Okay. Again, if you haven't finished this yet, don't worry. I know this is a little bit convoluted. There are so much stuff going on here. Don't worry about that. We can answer questions afterwards, and you can answer. You can also ask questions via Slack. Okay, let's go back to our last lesson in this session. That is, sorry. Oh, I just opened the wrong stuff. This is a lessons notebook. I want to go to my live lessons notebook. Here we go. Oops. This is not responding. Here we go. The last lesson is about classes. In previous workshop, actually we don't talk too much about classes, but when I decided to teach this class, I feel that I need to talk a little bit about it, because in tomorrow and the day after tomorrow, you are going to use a lot of PyMagine. Essentially in PyMagine, a lot of the stuff are classes. So I want to get you a very, very first basic understanding of what a class is and how you can create a class. Again, this is very basic, and also classes is a little bit difficult. So if you don't follow, don't worry too much. Okay, let's start by going over the syntax of the class. For class, if you want to define a class, you first use this class keyword. Then after the keyword, you type some class name. Again, by convention for classes, we use camel case. That means the first letter of each word will be in uppercase. Then optionally, after the class name, you can have a parenthesis. And within this parenthesis, you can have some super class that you can inherit from. If you don't have some stuff to inherit from, you can simply ignore it. So let me do this. In our examples, we will not use this case. We will do something simple like this. So don't worry about inheritance and something like that. We won't talk about it today, but you can check it out later. Then typically for classes, we may want some input, right? Here for a class, if you want to input some parameter, we use this init function. You may see this init function defined within this class is a little bit strange. It starts with 2_ and ends with 2_. Functions like this defined within a class are what we call Python class magic functions. So these functions, once you have defined them, Python knows what it is and will call it automatically at some time. For this init function, when we create a class, Python will automatically call this function to do some initialization of your class. Then let's forget this self first. Then in this function, it's just some parameter, very similar to what we do for functions. You can define as many parameters as you want for a class function, for a regular class function. Then one thing that is very special is the self stuff. You have to, for a regular Python method, you have to enter this, you have to put this self as the first stuff after the parentheses for the function. This part I will talk about more. Again, this is a little bit abstract. Let me do some examples. It will become much more clear. For this, let's define a class for 2-dimensional vectors. So we type class 2-dim vector. Follow our Python syntax here. We have to enter a colon. Then within this indented block, we type def __ init. Again, self. For our 2-dimensional vector, as we discussed before, for our function, we need 2 parameters, x, that's the x component of a 2-dimensional vector, and y. Then there's some magic happening here that I will type first and then tell you what it is. Self.a equals x, self.y equals y. So here self is some keyword. When you create an instance of this object, it will point to this instance. You can think of a self as some stuff within this class to keep track of the state of the class. Then you can then for your input variable x, you can assign it to some attributes, what we call here self.a. uses dot notation. This a will be an attribute of this class, and similarly self.y, let me do b. Self.b will be another attribute. We simply assign the value x and y into two attributes, a and b. I understand that I'm at the end of this time, but I hope I can have another 5 minutes. Just let me finish. I think that should be okay, right? If we want to end it early, the MP stuff, please let me know. But for now, I assume it's okay. Let me continue. We define this function. Then to create an instance of the function, you simply type the name. Let me assign it to some variable called vector vc. Then type the name of the variable to then vec, then a parenthesis. After this name of the class, you need to give your initial parameters that we define here at the init function. That let's do 3 and 4. So let's run this. When we run this, what Python does is that it knows this init magic function. When we create this class, this 3 will be passed to this x here, and the 4 will be passed to this y here. Note, remember that the self is a keyword. Nothing will be assigned to it. Okay, once we run this, we can check the attributes. And also when we assign this create instance to a variable vector here, you can think of this variable is the same as the self, because they are both pointing to the internal object of this class. Then we can get access to the attributes. Vector.a, it's 3, similar to self.a. You can simply think of self and vec are the same stuff. Then vector.b, it's 4. Here we go. It's the very initial stuff of our class. It's how you create a class and initialize. But the benefits of a class is that you can bundle your data and your operations on this data together. So let's define, for this purpose, you can define other functions. Let's define a function let's define a function to compute the magnitude of the vector, as we do before. Let's define a function called magnitude. Again, for this first stuff within this parenthesis, you have to enter self. After it, a colon. To compute it, we do what we do before. I have a typo here. I want to use B. I want to use A. Then we can return this magnitude. Remember here, if you remember, for our plan function to compute the magnitude of a vector, we pass the two values in as a parameter x and y. Here, we don't need to do that, because when we create an instance of this class object, we already initialize use this init function. Then we can get access to the values here using this self magic word here. Then self.a, as you know, is simply x, and self.b is simply y. So you see it is a little bit simpler here. Then we press Shift Enter to define it. we rerun this again, rerun it. Let's call this function vector dot, right? To call a function that is defined within a class block, you use this dot notation. We do vector dot get magnitude. Here, because we only have the self keyword here, that is some stuff you don't need to assign a value to. So for this function, we do not need any parameter. If we run this, it will simply get return this magnitude here. So again, you can do as many functions as you want here. For example, you can do if you want to scale a functor by some factor, scale the vector by some factor or something like that. So for the sake of time, I'm not going to add more, but I just want you to remember that this function that bundles data and some operations together makes management of the code a little bit easier. For this case, it's simple. You may not recognize it, but when you do complicated stuff, you have a lot of operations on some objects. This class stuff will benefit you or not. And also, as we said before, for class, you can also define a super class to inherit from. That will also simplify your code or not. Okay, just one last stuff. As I said before, class is a little bit convoluted. It is not easy to understand. So if you don't understand, don't worry. You can ask questions. And also, apart from this, there are a lot of tutorials online. You can check that. For this, I guess I'm running a little bit too late. So we may not go over the exercises, but let me show you what it is. You may want to do it by yourself, and also we have solutions there. For this exercise, for the class exercise, again, we deal with the conversion between temperatures. We create a class named the temperature. Then in this class, you will init some stuff. You will do some conversion between Celsius, Fahrenheit, and Kelvin. And also you have some defined function to do some operations. So here, I'm not going to go over this. I hope you can work on this afterwards. Okay, I guess that's pretty much I want to say for this lesson. I hope I have give you some idea of how you can work with, how you can define your own functions, your own classes. I hope you learned some stuff from this lesson. Thank you.